right, we're good. Well, welcome to the end of week 9. So I was doing some calculations, and after today, we've only got 7 meetings left for the entire course. We meet twice next week, and then 5 meetings week 11, and that's it. So we are rapidly coming to the end of this course.
Which date final again?
You got to check Canvas because it's whatever Clark's calendar says. So check the Clark website actually, because I think Canvas just says see Clark's website. But it's usually that first Monday of finals week.
We don't have class on Wednesday, do we?
We do not have class this coming Wednesday, correct. That's a holiday for Clark.
I have class that day for Bellevue.
Okay, yeah, but Clark takes the day off. And let's see what the exam schedule is. So for fall, 10 a.m. daily classes. So your final exam would be Monday, December 6th at 10 o'clock. All right. Other questions? I know it's been a fast quarter, and I mean it always seems like that, but this term in particular seems to have gone really quickly for me.
Yeah, same.
Yeah, I don't know why that is. I don't know if it's, I mean, we've been remote for a year now, so it's not just the remote thing, but I don't know. It's interesting, but we've covered a heck of a lot of material. We've gone through a lot of stuff, and so that's a good metric of time. All right, well, go ahead and send me an attendance ping. Let me know you're here.
I have a question about PA5 as I was working on it.
Go for it.
I can't think about how to scan multiple lines in a file without like using what I learned in PA4.
Dash.
All right, so let's see. This is topical. So there's actually a number of ways that you can loop in Bash to read input from standard in, or from a file, or from a command. So let's just look at ways to do this in Bash to read from standard in, because that's sort of the main topic for PA5. But we'll break this out more generally too. I can put my camera on. So let's just make a loop in Bash that reads input from a user one line by line, and at the end of all of the input, lets the user hit a Control D to say that they're done entering in things. So one way to do this was that we talked about earlier was something like this. Make an infinite loop. Read, whatever variable you want to read the input into. This is the usual read statement. But check your status variable. And if $? Is not equal to 0, you hit the end of the input. Either the person hit Control D, or you're redirecting from a file and hit the end of file, or you're redirecting from a command and the command has exited. So if $question is not 0, we can just say break, which takes us out of the loop.
$? Shows whether or not the program is running.
$? Always shows you the result of your previous command. So if I say, pwd and I echo $? It says 0, generally means the previous command was successful. And if I say ls, the previous command was successful. If I say I'm a cat walking on the keyboard and I echo $? It's non-zero now, which says the previous command failed. If I look at it again, it's a 0, which says the previous command, which was this echo statement, succeeded. But we can use this in a lot of different situations. So if I say ls, it will show me that was successful. If I look for a file that doesn't exist, and then I look at $? It's set to a 2. Well, that's the value that ls returns if you try to list a file that doesn't exist.
But if you do Control D, wouldn't echo $, that be marked as successful too?
So if I say, read line, and I say hello, $? is 0, and line has been set equal to hello. If I say read line and I just hit Control D, read line and Control D, $? will be equal to 1.
Okay.
So that's one hook we can use to figure out if input has terminated. So otherwise, if we don't break out of the loop, then line, in this case, since we said read line, is the next input line. And so we can, clean, parse, tally, etc. I'm just going to echo it here. And I'm going to say done. And then down here, we're out of the loop. And we'll just say we're out of the loop here. So if I run this without syntax errors, I can say hello, cool, other stuff, and then when I hit Control D, it tells me that I'm out of my loop. So that's one way to do this. There's another way we can do this, which is we can say while read line do, right? And this basically does the same thing that we just did. So it's a particular version of a while statement. So while read line, and as long as we have not hit the end of the file, we'll go into this body of the while loop. Line will be equal to whatever the line was that was just read. But when we encounter end of file through Control D or the end of a file, this statement will register as false. We'll kick out of the while loop, and we'll come out here and say we're out of the loop. Right, and then if I hit Control D, it tells me I'm out of the loop. So that's another option we can use. And that reads from standard in. Alright, so here's a sample file called test file. And if I run either of these programs and I redirect standard in from this test file, then instead of waiting for me to type information on the keyboard, it reads each line from the file. And when it hits the last line of the input file and it tries to read again, it gets the same response as if I had hit Control D on the keyboard. It detects end of file basically, and it says out of loop. And if I run this with loop 2, it should do exactly the same thing. So I can redirect standard in from a file, and this is typically how we would test PA5 with those test 0.in, test 1.in, and so on. Write your program to read from standard in, write to standard out, but then you can run it with an input from a file. And then if you want to capture the output, right, we can redirect the output with a greater than sign, and now we've got a file that has, the stuff that would normally show up on standard out. We can also, instead of reading from standard in, we can read from a file inside our bash script. So if we want to write a script that reads from, say, test file, we can say while read line do. We can put in the stuff that we want to do in the body of our while loop, and at the end we can say done, less than, and the name of the file that we want to read. Sorry, just a single less than. And instead of reading from standard in, it will read from this file. And so that's another option. Another option is we can read from a command. And we know we can execute a command. We can say, cal to get a calendar. We can take cal and we can pipe it into loop, and it will read each line of output produced by this command and process it through our script. So now we're reading, the output of a command one line at a time. When the cal program is done and exits and we try to read from standard in, we'll detect an end of file and we'll kick out of our loop. But if we wanted to hardwire this, right, we can actually write something which says done, put in 3 less than signs, back quotes, and the command we want to execute. And this is basically saying, hey, let's execute this command, let's capture the output, and let's read that output one line at a time. Each time that we read it, we'll store the next line of output in this variable, and we'll execute the body of this loop. When this command exits and there's no more input available and we try to read one more time, we'll exit the loop and we'll continue with our script. So if I run that, then I don't need to specify any input, and in fact it would ignore any input that I specified, because the while loop's reading from the output of a command. So we can do all kinds of things in Bash as far as reading reading from something other than just the keyboard, other than just reading a single line.
You explain like the difference between the 3 less or greater than signs versus the 1 again. This is
So use
3 if you're executing. Go ahead.
Yeah, no, I think you were about to say it. If you're executing a command and capturing the output, right, use 3 less than signs and put your command in back quotes. If you're just trying to read from a file, just use 1 less than sign in the name of the file.
Okay, thanks.
Mm-hmm. All right, good. Other questions?
So you can pipe anything you want into any loop like that, basically.
Mm-hmm. Yeah, Bash, you can make any pipes that you want. Using this 3 less than sign trick, right? We can execute a command inside Bash, and I can ls /etc.
Would you do the same to like an if statement? You pipe it into the fi statement.
So it doesn't really. It's not as well defined what we would mean by trying to do an if statement on the output of a command, for example. This is really kind of one particular type of while loop, which is while read line. I don't know what the analog would be for an if. But this is for iterating over each line of output produced by a command, and then you can do whatever you want with that. So you might have, conditional statements inside here, for example. And that can be any command that's legal and executable. If you try to execute something that you don't have access to or that doesn't run right, then who knows. And if I were to put in the name of the script here, I'll probably crash my machine, because that's basically well, it's like a fork bomb. I would be asking my bash script named loop3 to execute loop3 and capture the output, and when loop3 tried to execute, it would go through this code and it would say, oh, I have to execute loop3, and I'd run out of process slots and possibly crash my machine. It's remarkably easy to crash a Unix machine if you don't put restrictions on what users can do. So I don't have any restrictions on my laptop, so I'm not going to do that. But you can try that in the VirtualBox if you're curious.
So I'm looking to find a way to test my main program by using test1, test2 in your Homer file, but for some reason it says it doesn't exist. So can I find where to locate it and maybe copy those into my directory so that way I can have main run it?
You can do that. All right, so here's my main program. So I could say main less than /temp /pa5 /test0.in, and it reads that as an input file and executes my script. Now, if I want to do this on my own laptop, I could just copy this file from /temp pa5 on the server, make a copy of it on my laptop, and then use it. But if I want to compare this to the output, right, I could if I look at test0.out, test0.out, I've sorted these numerically, so this does not look exactly the same as this. But what I can do is I can run main less than the input file, and I can pipe that into sort-n, and that shows me the sorted output. And if I want, I can redirect that into my output. So now I've got my output, and I can look at the approved output, and I can see if those are the same. So this should be exactly the same as that.
Do we have to sort our files, or
only if you want to more painlessly compare it to the approved output. But for PA5, you're not required to sort.
Okay, thank you.
Yep. So if I want to know if these, yeah, go ahead.
There was a command you put on the PA5 of how you're going to be doing the comparison. And I don't know if you meant for students to copy it, because I tried, and it gives you a permission denied error.
Oh, let me see. Do you remember where it was?
Yeah, it's the up, I think, right there, the main, that right there.
Okay. Yeah, so as long as this is in your current directory, this should work great. If this is not in your current directory, put in the path to it.
Right, I did, but it gave me a permission denied error. Like I didn't have permission to run the file or something, I don't know.
Well, try running it, see if that works. Try running it and reading it from this, see if that works. Try running it, reading from this, and piping into sort, see if that works. Try doing the whole thing, see if that works. Figure out where the permission error is coming from. If you're in your own directory you should be able to do all of these things as long as you put in a path. If you're sitting in temp PA5 and you try to redirect the output to test 0 out of it, that'll give you a permission error, because that's a file that I own. But if you make a copy of test 0 in to your own directory and you run this from that directory, everything should work. But if not,
Okay, yeah, I was piping it. I was piping it to /temp out.
oh, okay, yeah, that file already exists, so it won't let you change it. And if you've got a copy of, you know, your output, and you can get to a copy of the approved output, and you want to know if they're the same, you can stare at these, right? Which is not very much fun. In the old days, we used to print them on transparent paper and then hold them up to a light, you know, and you could find differences like that. But if you got Linux, you can use a difference command, so you can say difference myout, and just difference it with test0.out. And if you don't get any output, that means there's no differences. If you've got a problem with your count where it thinks a cow barked loudly 3 times, and you run the difference command, it'll say, hey, in your file, that's what the less than sign is, a cow barked loudly 3 times. In the test.out file, a cow barked loudly 2 times. And so this difference command will help you pin down differences, especially when you run this on the big file with a few thousand lines of input. If you do the diff and it comes back without any output, you're golden, right? It means your output matches exactly. And that's pretty much what I do for first order grading on this assignment. I'm just going to write a script that will run, you know, this kind of command on your script, and do a difference between this and temp PA5 test0.out, and do that for the 4 tests, and then run some other tests that I haven't published. And you know, if all of those come out matching exactly, then I don't need to do any more testing on your program. I go in, I start looking at the code, the commenting, things like that. And the tests get increasingly difficult for the program, basically. The test 0 is pretty much simple text. Test 3 has got all kinds of weird characters you need to ignore, and, you know, multiple spaces and all kinds of things like that to deal with. So yeah, definitely take advantage of those. All right, other questions?
Could we go back to the readline command you were doing earlier, the while loop?
Mm-hmm.
What is, so does readline, if it reads a line successfully, then it returns a 0? Is that?
So if readline succeeds, $? Will be equal to 0.
But what in the other script that you wrote, where it just said while readline,
Mm-hmm.
it was reading, so it's reading readline, and if it successfully reads a line from the file or whatever, then it will return to while.
Mm-hmm.
What is it returning to while? The readline statement there.
So while does not return anything. While is like a while loop. It's like while, you know, x is equal to 0 or something. So this says read a line, and if it succeeds, go ahead and execute whatever's in the body of the while loop, the stuff between do and done, and then come back up here and try another line.
Okay, I guess that's. I guess I'm just trying to figure out exactly what it is that readline is returning to the while loop, like if statement, but that makes sense enough.
Yeah, it's not really. I don't think you can just say while and put in an arbitrary statement in here. At least I've never tried that. I think of it as a different type of a while statement, just like a for in is a different type of a for loop. This is a different type of while loop, which says read a line, and if it succeeds, do the body of the loop. If it fails, the while loop is done, and, you know, come down past the done statement.
Okay. Sorry.
Okay.
Thank you.
Yeah, you're welcome. All right, good. Other questions? All right, awesome. Let's go back to regular expressions. And I have our Canvas page. Oh yeah, don't forget your SLP upload. I think that's coming up on, is that Tuesday? Tuesday's the 23rd. So make sure you get your poster uploaded by then. All right, so up here in this first section, the general course information, there's two items down here at the bottom. One is called regex summary, the other is regex practice questions. So these are synopsises of what we were talking about yesterday. So regex summary, main things to know, right? Anchors for the beginning and the end of a line, wildcard to match any character, star to match 0 or more of the previous character. I don't know why that says ... Yeah, it's eating something. So parentheses, stuff, close parentheses, you specify a pattern in here. Whatever matches that pattern gets put into a register, starting with register 1, register 2, and so on. And then on the right-hand side, you can say \, 1, 2, etc., and pull the contents of that register out. And I don't know why that's eating those. Let me see if I can fix this quickly. Nope. This is hideously ugly now, but it works. So expressions inside these \/ parentheses say take whatever matches, put it into a register, and then \/ register number replaces this expression with whatever you matched in the corresponding register. Any character will match that character unless the character is special, like a period or an asterisk or a $sign or things like that. If you want to match a special character, you can put a \ in front of it. So \$ $sign looks for an actual $sign instead of you know, the end of a string. After is it at third line, is it new line. I don't know where that is. It is new line. You can put things inside brackets, and for example here would match an X, a Y, or a Z, and with a caret in the front of a set of symbols, it will match anything except one of those symbols. Alright, let me see, previous question. Try to format with the third and fourth line, a test it is. The test.
I have a little question.
Mm-hmm.
So, whenever you work with sed, you're basically giving it a regular expression.
For what we've been doing, yeah.
Okay.
And sometimes it doesn't look like a regular expression. Sometimes it's just, you know, substitute /old /new. And it's just a set of characters we're trying to replace, change a variable name or something. But it's just a really sort of simple regular expression in that case. Let's see. So there was a question in chat about test1.in, third and fourth line. I don't think I can do that in my head right now. but maybe send that to me in an email or come by office hours. Yeah, definitely. That will work well. All right. Yeah, you're welcome. Are we going to have any more ODPs for the rest of the course? I think so. I got a few CODPs that I want to run by you that maybe I'll post on Monday. And I think I want to do a few ODPs for SED and AUK, but we're definitely winding down, and then we'll come back with a lot of ODPs in 222. And we'll get back to almost daily versions of those for a while. Alright, so you can use these regular expressions in VI, you can use them in SED, and the syntax is the same. In VI you can say colon s/old/new. In SED you can put that inside the command after the word SED. And if you do a G at the end, it says do all occurrences of this replacement on a line. And so, if I VI my test file, I could say :1, $, substitute, right, I could say get rid of everything except the last word on the line. So I'm going to start at the beginning of the line and, let me just do this. Start at the beginning of the line, match any succession of characters followed by a space. Regular expressions are greedy, so on this first line, yeah, THIS, that's a set of dots followed by a space. But I can also say THIS space is a space, go all the way up to here, and all of that highlighted text matches this pattern. Beginning of the line followed by a series of characters followed by a space. That's the most number of characters I can consume with this regular expression. So that's what's going to match, and that's going to get replaced with nothing. So this should delete everything except the last word on each line, and I'm saying do this between line 1, the first line, and $, which is the last line of the file. And so that, just leaves me with the last word of each line. So here I'm matching a pattern from the beginning of the line. I'm looking for any succession of characters followed by a space, followed by any succession of characters, followed by the end of the line. And so I'm using two registers. Register 1 is going to contain everything up to the last space. Register 2 is going to contain the last word. And if I replace this with $2 and ... and $1, this should change. This is a test to test ... This is and do that kind of thing on every line. So we can write expressions like that in SED. We could say SED quote all of that stuff, send it something to standard in, capture standard out. We can also do these in VI. If I do this on just one line, I can replace ha with uppercase ha. Alright, so and just some reminders on bash, right? We can say line 1, comma, line 2, substitute old, new. You can do 1, comma, $. $, is the last line of the file. Dot is the current line, and you can do arithmetic. So for example, if I wanted to, get rid of or uppercase the letter E on the next two lines, I could say dot, comma, dot plus 1, substitute E with a big E globally. Dot is my current line, which is a grand test. Dot plus 1 is let us celebrate. And so on those two lines, I'm going to make this substitution. Right? But it did not change it anywhere else in my file. And this is in the spirit of all things VI that I tell you about. You don't need to memorize this. You don't need to force yourself to use it, but you should make a note of it somewhere. Scribble it down on a piece of paper, or, you know, make a little hints file or something. And you know, someday you'll be in a file where you want to make a change on, you know, these 50 lines of your file, or, you know, all the lines in this one function or something like that. And you can go through and do it character by character or line by line, but something like this is a huge huge time saver potentially. And so if it works for you, right, you'll be like, hey, that's pretty cool, and you'll remember it, and next time you'll use it again, and so on and so forth. And sometimes, you know, you got a big huge file here, and you want to change grand between here and here, so maybe you just Control G and note this is line 7. So come down here and say :7, dot. And I'll make that change. And so it does it on just that section of my file. So stuff to play with. Alright, but back to regular expressions. So there's another item posted here, which are these regular expression practice questions. And I want to just play around with these for a few minutes. We've got about 12 minutes left in class. And, you know, normally in person, we'd go to the board and I'd have people work on these in groups. I don't want to get into breakout rooms right now. But let's just work through these. And if you want to respond in chat, you can do that. So how do we remove the first occurrence of Q from a line? Go ahead and send me some regular expressions in chat.
Goes privately or like to everyone?
You can do a direct message if you want. That's a fair answer. Cool. So for modifying a line, where we're just, you know, replacing one thing with another thing, or getting rid of something, which is basically replacing one thing with an empty thing, right, this would certainly work. Look for an occurrence of the letter Q, and these expressions start with the beginning of the input string. So they start at the beginning, move until they find a Q, in this case, replace it with a slash, with you know, the stuff between the slashes, which is nothing. That basically gets rid of the Q. And because it starts at the beginning of the line, it would get rid of the first occurrence of the letter Q. And if I put a G at the end, that would get rid of every occurrence of the letter Q, because after it gets rid of the first Q, it will continue searching for another thing that matches this pattern, which would be a second Q. Get rid of that, continue searching for a third, and so on. But what if we wanted to remove the last occurrence of the letter Q? This is super duper significantly harder. So we definitely want to use the $sign. We want to pop that one out. So if we knew the Q was at the end of the string, we could search for Q $. If we knew that the Q was 2 characters from the end of the string, we could search for Q ... and a $. And we could throw these in parentheses and replace this with what got matched in those parentheses. And if we knew that there was a Q followed by 4 things, we could match this. Q followed by 4 characters followed by the end of the string. And replace that with the thing that came after the Q. But of course we don't know how many characters come after the Q. But we know how to do a wildcard that lets us count, 0 or more occurrences of something. So we could try something like Q and then any number of characters followed by a $. And that would work, except that regular expressions are greedy. They want to consume as much of your input line as possible. And so if we did this, the regular expression matcher would say, oh, here's a Q, here's a bunch of stuff followed by the end of the line. All of this is going to end up matching, and this is just going to remove the first Q still. So what could we do instead of a dot star? This is really subtle. Yeah, we would put said before all of these expressions. So we could flip the dot star and Q. We could do that to make sure that we're matching stuff before the Q, but we might have some stuff between the Q and the $ at the end. So we still need some way to specify this stuff.
Ampersand?
What about an ampersand?
Put an ampersand in place of the dot star. And put the $ in front of the Q or something?
Something.
I don't know.
So no, I mean that's a reasonable direction. Think about what we've got so far. We've got basically these things to choose from.
What about the case in which we don't know where the last Q is in a string?
Yeah, that's the problem we're faced with right now. We don't know where the last Q is. If we knew that there were 4 characters after it, we could do something like this. But we don't know how many characters come after the last Q, so we've got a dot asterisk. The problem is dot is too powerful. Dot will match any character, including Qs. So we want to use something... Say again?
Sorry, take out the dot?
Well, if we take out the dot, then we're not telling it to match anything. So we need something that will match a character, but not match a Q. Something just a little less powerful than a dot. So is there a way we can say match something other than a Q?
The brackets with the
Yeah.
caret.
Let's use the brackets with the caret. So if I say substitute Q, and then let's look for anything that's not a Q, and let's look for any number of those things followed by the end of the string.
We can't see your paper.
Oh. Thank you. Let's search for a Q, and then look for something that's not a Q, and match any number of things that are not a Q followed by the end of the string. Then all of this is the stuff that comes after the last Q. And we'll throw that in parentheses, and we'll replace all of this with just the contents of what matched this pattern. And so in this case, it would say, okay, well, here's a queue, and it's followed by things that are not, you know, a queue. Well, that gets me this far, but that's not the end of the line. So it can't match this pattern starting here. And it'll try starting from here. There's a queue. There's some things that's not a queue, not a queue, not a queue. That's as far as it can go. That's not the end of the line. So it'll try it from here. Here's a queue. Here's something that's not a queue, not a queue. There's the end of the line. Oh, this matches. So this will match this pattern. And the stuff that came after the queue, which was these two letters, that'll go into register 1. And so this substitute statement basically says take these 3 characters and replace it with just these 2 characters. And so we can try that. So said substitute queue followed by not a queue, any number of those followed by the end of the string. And let's take the thing that matched all of this and put that in parentheses. And we have to escape our parentheses.
Oh, never mind.
There we go. Thanks. And so that preserved the entire string except the last queue got dropped out, and then the stuff after the last queue remained. And you know, I don't know anybody who memorizes these things, right? That's not a fruitful use of your memory. You memorize these things, right? And you get experience trying to put those things together to do things like, you know, remove the last queue from a string. But this stuff, you know, gets sort of synthesized on the fly. When you want to do something with a regular expression, that's when you kind of figure out how to put those you know, several commands that we have together to achieve some goal. So if you look on Canvas, there's some practice problems here. These are good things to play around with. I would say try to work on these over the weekend. They're not going to be graded, they're not going to be collected, but we'll probably talk about them on Monday. In particular, if you have questions, if there are ones here that you couldn't figure out how to do, we can talk about those. So, you know, basic patterns: remove the first queue, remove all the queues, remove any occurrence of th, remove any occurrence of t followed by any character. So using, you know, like a dot as a wild card. And then anchors, trying to do things specifically at the beginning or the end of a line. And then some things playing around with the registers. Remove the first 3 and last 3 characters from a line. Swap the first 2. We did that yesterday. Swap the first and last characters, and so on and so forth. So, you can mess with these if you want, right? And it's a good way to get better with regular expressions. You'll probably see some sort of question about regular expressions on the final, where I'll say, you know, write a regular expression to do such and such, or something like that. Remember, I gotta grade them, so it's not going to be too brutal, because I can't, you know, grade 60 questions with backslashes and parentheses and all that kind of stuff. So if I do that, I'll find a way to make it fairly straightforward. All right, so that's it for our Friday. So send me an attendance ping on the way out, please, and have a great one. I will see you next time.